Welcome to our channel. In the last video, we discussed CAMS and follower module. In that, we completed the topic Introduction to CAMS and types of CAMS, in which the basic shapes, according to basic shapes. So we know that CAMS are classified according to basic shapes, follower movement, and manner of constraint of the follower. So in last video, we completed according to basic shapes. Let us move on to the next classification. According to follower movement, we have rise, return, rise, dwell, rise, return, dwell, dwell, rise, dwell, return, dwell. These are the three follower movements. So here I would like to express what I mean by dwell. So dwell is a zero displacement, or we can say there is no motion at all for the follower during cam rotation, during the motion of the cam. The motion of follower are distinct from each other by the dwell they have. So one can say dwell means even though the cam may have some motion, the follower doesn't have any corresponding motion. Let us discuss rise, return, rise type of follower. So in this, there will be alternate rise and alternate return for the follower with no period of dwell. Here we can see there is an absence of dwell. So follower will have continuous motion. Either it may have rise motion or it may have return motion. So follower has an angular or linear displacement, but the thing is it has very limited application in industry because dwell are preferred in industrial application. Therefore, rise, return, rise will have very limited in application in industries. Whereas dwell, rise, return, dwell, in the displacement diagram we can see at the beginning we have dwell, and after certain amount of cam rotation, a rise is accomplished and followed by return and followed by dwell. So in such type of cams, there will be rise and return of the follower after dwell. So this type is frequently used rather than the previous type of cam. And some more type is dwell, rise, dwell, return, dwell. Here we can see dwell at after, before rise and after rise also, and before return and after return also. So the dwelling of cam is followed by rise as well as dwell and subsequent by return and dwell. We can see there's a figure C and figure D. In figure D we can see dwell, rise, dwell, return followed by dwell. That depends upon the application actually. And in figure number D, we can see there's a sudden fall. In case of return of the follower is by fall of motion, known as dwell, rise, dwell, as shown in figure number D. Here we have sudden fall. So dwell, rise, dwell. So this is called as dwell, rise, dwell type of follower displacement. So this type of cam are also commonly used. The next classification is according to the manner of constraint of the follower. To reproduce the motion transmitted by the cam to the follower, both should remain in always contact at all speed at all time. Right. So to make the cam and follower remain in contact together in the manner of that constraint, we have classification. We can call it as preloaded spring cam, positive drag cam, and gravity cam. Let us discuss these three one by one. The preloaded spring cams, we can see we use a pre-compressed springs for the follower. To the purpose of this using the springs is to keep in contact the cam and follower. So in these three diagrams, wedge cam and knife edge follower is with a spring. The pre-compressed spring will make sure the follower will be always contact with the cam. That's why this type of cams is called as pre-loaded spring cams. Whereas positive drive cams, here the springs will not be used, but the contact between the follower and cam will be such a way that we will get a positive drive. We can get very less slip between cam and follower. There will be constant touch between cam and follower is maintained by roller follower operating in the groove of the cam. In the diagram we can see there will be groove. So this is plate cam. Here also we have groove. Here we have globoidal cam, convex type and concave type. That also consists of groove. So we can easily get a direct contact between the follower with the cam with the help of groove. So the follower cannot go out of this groove under normal working condition. Hence the drive will be positive. A constrained or positive drive is also obtained by using conjugate cam also. In this diagram we have shown plate cam, globoidal cam. Using conjugate cam also we can get a positive drive of cam. The third type of cam is gravity cam. As the name itself indicates, here we will not use any pre-compressed spring. If the rise of the cam is achieved by rising surface of the cam and return of the follower wheel is due to the gravity force or due to its self weight of the follower. Therefore, it's also called as gravity cam. However, this type of cam will not be preferred to use because we can't predict the motion of the follower. Let us move on to the next topic, that is types of followers. The types of followers can be classified according to three headings: according to shape, movement, and location of line of movement. Let us discuss one by one. The follower according to their shapes we can call a knife edge follower, a roller follower, a flat follower, a rounded or curved follower is also sometimes called as spherical follower. These are the diagram for the follower shapes. So knife edge follower, as you can see, this is the follower which consists of a sharp edge at the end of the follower. It's called as knife edge follower. In roller follower, we can see a roller will be in contact with the cam. Hence, the disadvantage of knife edge follower is that we may get more wear and tear that can be reduced with the help of roller. So less friction arises in case of roller follower and smooth rotation we can get. The flat face follower diagram is shown here. Instead of roller, a flat face will be in contact with the cam. Then finally, spherical face follower is also shown here. It's also called as rounded or curved or mushroom face follower. So this is the types of follower according to their shapes. It's very easy to remember, but by referring their shapes, we can call the names. Let us discuss one by one. The knife edge follower, as the diagram is shown, is very simple in construction, but its use is very limited because it produces great wear of the surface. Due to the sharp edge of the knife edge follower causes more wear and tear, and it raises more contact stresses. The roller follower overcomes the disadvantage of knife edge follower. It gives us a low friction and low point stresses, hence it's widely used. It has cylindrical roller which is free to rotate about the pin joint. In the diagram you can see this is the roller, is very free to rotate about the pin joint, and it can rotate at low speeds, and follower has pure rolling action, but at high speeds some sliding also occur. So the roller is having a small limitation that at high speed sometimes it may slide. So in case of steep rise, the roller follower jams. This is the most disadvantages. So if we have a steep rise like this, assume you have wedge cam like this, wedge cam sudden rise. So if the shape of the cam is like this, so sometimes the roller faller jams. Therefore, for steep rise and steep fall, roller faller is not preferred. Mushroom faller, it doesn't pose any problem of jamming at all. There is the most advantages. However, high surface stresses and wear are quite high due to deflection and misalignment. If a flat face faller is used, these disadvantages are reduced if the spherical face faller is used instead of flat face faller. So the disadvantage of flat face faller can be reduced if we use spherical face follower. It's also called as mushroom follower. The next classification is according to movement of follower. So follower may have reciprocating motion, it may have oscillating motion also. So depending upon their motion, we have reciprocating follower. So when cam rotates, if the follower is achieved reciprocating or translation motion is called as reciprocating follower. So this figure C indicates the reciprocating follower. Here we used knife edge follower to show the reciprocating follower. Then oscillating follower, the follower is pivoted at a suitable point. See here we have pivoted. The follower is pivoted at this point. So when the cam rotates in this direction, the follower oscillates. So the rotary motion of cam is converted into oscillating motion of the follower. Then we have the classification according to location of line of movement, the inline follower. So when the axis of the cam, see this is the axis of the cam, the center of the cam is in line with the center of the follower, we call it as it's a inline follower. That is, the follower is known as radial follower if the line of movement of the follower passes through the center of rotation of the cam. So if these two are not in line, that is cam axis and follower axis are not in line, that is called as offset follower. Here you can see the line of movement of follower is here. This is the line of movement of follower, whereas the cam rotation is here about this axis. The distance between these two we call it as offset. So this is the offset roller follower diagram, and this is offset flat face follower, and this is offset spherical face follower, the last right hand side diagram. This is spherical face offset follower, in which the line of action will be offset from the center of rotation of the cam. Let us move on to the next topic, that cam nomenclature. So the cam nomenclature will be having, this is the diagram to explain cam nomenclature. We come across trace point, pitch curve, cam profile, then prime circle, base circle, right? Then pressure angle, pitch circle, total fall or travel is also called as lift. So these are some important terminologies we use in cam. Let us discuss one by one. So the cam profile is actually the working surface on the cam. It's very important because the follower follows the cam profile. So in this diagram, the thick line what we shown, that will be the cam profile. The thick line what we have, that is a cam profile, right? To get this cam profile, the remaining terminologies will be act as a construction lines. The dwell, we already discussed what is dwell. There's a period during which the follower is at rest. And base circle is the smallest circle that can be drawn to the cam profile. See, the base circle means the minimum radius of the cam. So just know what I'm writing. There's a base circle. There's the smallest circle while drawing the cam profile. Then prime circle is the smallest circle drawn to the pitch curve from center of rotation of the cam. So this prime circle will come whenever we use roller follower. So the center of the roller follower will be considered to draw the prime circle. The dotted circle what we have here, that will be called as prime circle. Then pitch curve, it is a curve generated by the tracing point as the follower moves relative to the cam. The pitch point is the point on which the pitch curve having maximum pressure angle. In diagram we can see the pitch point is here, where at which the pressure angle will be maximum. The pitch point is shown here. Then pitch circle is the circle drawn through the center and pitch point. If you draw a circle keeping the compass leg at the center of the cam, and if you touch the pencil to pitch point, a circle obtained through this radius is called as pitch circle. And trace point is a reference point on the follower. We commonly use this trace point to get the pitch curve. And in case of knife edge follower, the knife edge itself traces will be called as a trace point, whereas in a roller follower, the center of roller will be considered as a trace point. And cam angle is the angle turned through by the cam from initial position, like it's rotated 30 degree to rise, then 40 degree to dwell, and 90 degree to return, like that. That is cam angle. And pressure angle, as we know by definition, is the angle between instantaneous direction of the follower motion and normal to the pitch curve. We have lift, it's also called as throw, it's also called as stroke. It's the maximum travel of the follower from the lowest position to the topmost position. So after achieving a movement from lowest position of cam to the topmost position of the follower, lowest position of follower to the topmost position of follower, the total distance we call it as a lift. Then follower displacement, we know as the cam rotates about its axis, it gives a specific motion to the follower, which repeats with each revolution of the cam. Then angle of ascent. So ascent or rise both are same. So angle of rise, angle of ascent is nothing but it's the angle of rotation of cam during that time the follower rises. So for example, if you rotate the cam by 30 degree, if the follower is raised means that's called as 30 degrees called as angle of ascent. Angle of dwell means if you rotate the cam for a certain angle, during that angle, the follower remains constant. If the follower doesn't move at all, that angle of rotation is called as angle of dwell. And angle of descent is also called as angle of return. So it's the angle through which the cam turns during this time the follower returns to its original position. It's coming back to original position. Then angle of action is the total angle moved by the cam during the time between the beginning of rise and end of the return of the follower. We have different types of follower motion. Some of the common types of follower motions are constant velocity. It's also called as uniform velocity. Then simple harmonic motion, popularly known as SHM. Then uniform acceleration and deceleration motion. It's also called as uniform acceleration and retardation motion, UARM. And finally, cycloidal motion. So these are the type of motion the follower may have. While drawing the profile of a cam, one has to take care of this type of motion of the follower, because the displacement diagram depends upon the type of follower motion. We have different procedure to draw the displacement diagram for each type of motion that we will learn while drawing the cam profile. This completes today's topic. Thank you